Today we will be talking about mixed operation two-step word problems. When we say mixed operation, we'll be talking about using any one of the four operations of addition, subtraction, multiplication, or division to solve a word problem that requires two steps. So students will be doing two equations or two operations. They might need to multiply 2 times in a row to answer the question. They might need to multiply then subtract. It really depends on what the question is asking and the actions happening in the story, which students need to learn to match to the appropriate operation. In order to help us be more successful and to really think about the story and slow down a little bit when we're solving word problems, we have been using the problem-solving steps in class. And I encourage students to use them every single time that they are doing a word problem. It is forces them to really think about the problem, and for students who read a word problem and feel a little overwhelmed and have no idea where to even start, they can definitely get through the first 3 steps on the problem-solving steps and feel like maybe they haven't maybe solved it, but they're on the right track. So we're going to go through hopefully a couple problems today and give you a feel for how the problems might look and how we are solving them in class. So step 1 is to read carefully and to visualize. And I really have been talking a lot with students about visualizing the actions, because the actions are what we need to match with an operation. So I'm going to read the problem. Jonah has 6 boxes of markers. Eric has 5 boxes of markers. Each box has 8 markers. How many markers do Jonah and Eric have altogether? So you read carefully, you kind of picture 2 boys with different numbers of boxes of markers. You know how many markers are in each box, and they're asking how many do the boys have together. So if I added Eric and Jonah's together, what would I have? Step 2, pull out important information. What this means is we read the problem again, and then we are going to kind of tickle notes for ourselves of important information, important numbers that we think are going to help us solve the problem. So I see that Jonah has 6 boxes, and these notes can be quick. I could do J for Jonah. Jonah has 6 boxes. E has, see, I caught myself a mistake right there. No, he has boxes. Oops, I was getting confused with boxes and markers. E has 8 boxes. Eric has 5 boxes. Each box has 8 markers. Okay, so in each box that the boy has, there are 8 markers. How many markers do Jonah and Eric have altogether? That takes us to step number 3, is an answer statement. An answer statement is just writing a complete sentence where you can fill in your answer. We don't know the answer yet, so I'm going to leave a blank for that. So I take the question and I restate it in a sentence. How many markers do Jonah and Eric have altogether? J and E have blank markers all together. I'm going to squeeze that over here. Period. So I don't know that answer yet, but I'm going to come back to that at the very end, step 6, and fill that in and think about whether I've answered the question, if it makes sense or not. Now that I have kind of pulled out my information, I've read it a couple times, hopefully I have started to think about what operations will help me solve it. And so I'm on step 4, where I'm making a solution plan. And it's really okay for students to be kind of talking it out loud if they want to, or having a little conversation in their head about what to do about this. So for a solution plan, I know I need to add up how many markers they have, but right now I only know their boxes. So I need to figure out how many markers are in each boy has. How many markers do they have in their number of boxes that they have? Once I figure that out, then I can go ahead and answer the question. There are probably several ways that a child could approach this problem. So the way that I'm showing might not be the way that you even think of that you would solve it. But also that's a part of being a good mathematician, is thinking flexibly about solution strategies and how there's not always one right strategy to get to the right answer. So what I'm thinking is that if I add up their number of boxes, find out how many boxes the boys have all together, then I can take that number of boxes and times it by 8 to figure out how many markers they have all together. So my solution plan is that I need to add and then I need to multiply. And what I'm going to add is 6 plus 8 is 14, 8, 9, 10, 11, 12, 13, 14. Yep, see, checking on my fingers, still okay in 4th grade. If they're checking on their fingers or need their fingers, that is okay. Again, we aim for fluency, but if they don't have it, they need another strategy, fingers still work. So I have 14 boxes of markers. Each box has 8, so I have 14 groups of 8. That is a clue to me that it would be a multiplication equation. So 14 times 8 equals m. All right, so I have a 2-digit by a 1-digit multiplication. Our strategy for that is the area model.